Assalamualaikum warahmatullahi wabarakatuh, sir. Dan salam sejahtera. Saya 2240258 Ikhwan Aizat bin Saiful Azhar daripada Kumpulan 3. Pada hari ini saya akan membentangkan tentang salary data report. Introduction. In today's data-driven world, understanding salary trends based on various demographic and professional factors is crucial for workforce planning and career decision making. This report analyzed a dataset containing 1,000 entries to investigate how features such as education level, experience, job title, gender, performance score, location affect salary levels. The findings aim to contribute insight for HR professionals, job seekers, and data scientists who are working on predictive salary models. So, the primary objective of the report are to explore the relationship between salary and factors such as education, experience, job title, location, gender, and age. Second one is to visualize the trend and patterns in salary distribution. The third one is to build a simple predictive model to estimate salary based on key attributes. And the last one is to identify which features have the most significant impact on salary.
Assalamualaikum sir, saya 2240256 Ahmad Umar Imam Bekari Syam will present about scope. This project focuses on analyzing and predicting salary based on demographic and job-related features using structured dataset. The scope is defined as follows. First, we got included in the scope analysis of key variables: education, experience, job title, location, age, and gender. Next, we got visualization of salary trends based on different features. Next, development of basic salary prediction model using linear regression. And lastly, use of Kaggle for data analysis modeling and evaluation. Second, we got excluded from the scope. First, real-time or live data collection. Next, advanced modeling technique, for example, ensembling model and deep learning. After that, we get external validation or deployment of the model. And lastly, we got ethical or legal analysis of salary bias or discrimination. By maintaining this focus scope, the project delivers actionable insight into salary drivers while laying the groundwork for future predictive modeling enhancement. Data descriptions. This dataset includes 1,000 records with the following variables. The table below shows variables, type, and descriptions. For example, in the categorical type, we can get education, location, job title, and gender. And while for the numeric type, we can get experience, age, salary, and performance score. That's all from me.
Assalamualaikum sir. I am 2240271 Muhammad Faris Danish bin Amdan. Okay, next I will explain about methodology. The data source is the data set contains 1,000 entries with 7 columns, include education, experience, location job, title, age, gender, performance score, and salary. The tools that we use is Kaggle. It is for data analysis and model development using Kaggle notebooks. Okay, next is steps taken. First, download the dataset from the source and uploaded it to a Kaggle notebook for analysis. Secondly, inspected and cleaned the dataset by checking data types and ensuring there were no missing values. Third, perform exploratory data analysis using Kaggle's notebook tools. Generated summary statistics for each feature, created visualization like bar chart, box plots, and histograms to explore data patterns. Fourth, encoded categorical variables. For example, education, gender, location, and job title using one hot encoding. Fifth, split the dataset into training and testing sets to build and validate the model. Sixth, develop a linear regression model using the training data to predict salary. So next is data. The following data is include education, experience, location, job title, age, gender, performance score, and salary. Okay, so as you can see here, this is 1,000 data sources.
So for our demography, first of all, experience table. From its frequency table, it shows how many individuals fall into each experience range. Most individuals have 16 to 21 years of experience, while the fewest individuals have 26 to 31 years. Chart insight. A peak is seen at 16 to 21 years, indicating it is the most common range. It decreased after 21 years of experience. So for age table, from its frequency table, balanced age distribution across the multiple range. Highest frequency in 60 to 65 years old. So from its chart insight, two minor peaks around 20 to 25 and 60 to 65, indicating younger and nearing retirement groups. Lastly, performance score table. From its frequency table, most scores lie between 3.0 to 4.5, while few scores below 2.0. From its chart insight, performance is positively skewed. More people have higher scores. So let's analyze the question that we get. First of all, what are the response and predictor variables? Firstly, response variable, which is dependent variable, is salary, which is employees' annual income. Second, predictor variables, which is independent variables. There are two answers. Firstly, numerical, which is experience, age, performance score. Second is categorical, which is education, location, job title, and gender. For the second one, what is the hypothesis that is being tested? Overall regression model hypothesis. Firstly, null hypothesis. All regression coefficients are equal to 0, which is none of the predictors significantly affect salary. Second, alternative hypothesis. At least one regression coefficient not equal to 0, which is at least one predictor significantly affects salary. Individual predictors, t-test for each coefficient. Third, null hypothesis, which is beta I equal to 0. The predictor has no effect. Lastly, alternative hypothesis, beta I not equal to 0, which is the predictor has a significant effect. For the third question, let's construct the ANOVA table and test for significance of regression. For the response variable, which is salary, predictor variable, which is experience. There are 5 steps. First of all, step 1, hypothesis. Null hypothesis, beta 1 equal to 0. Alternative hypothesis, beta 1 not equal to 0. Step 2, we need to do the f-test. F-test equal to 133.7573. Step 3, critical value. F 0.05 1.997 equal to 3.84. Step 4, compare and decide. Since f-test is 133.7573 is more F critical 3.84. So we reject null hypothesis. Step 5, conclusion. At alpha 0.05, there exists a statistically significant relationship between experience and salary. So for the second one, which is response variable, is salary. Predictor variable is performance score. So we need to do those 5 steps again. Step 1 is hypothesis, which is null hypothesis, beta I equal to 0. Alternative hypothesis, beta I not equal to 0. Step 2, f-test. F-test is equal to 2.8444. Step 3, critical value. F 0.05 1.997 equal to 3.84. Compare and decide. Since F-test 2.8444 is less than critical value 3.84, fail to reject null hypothesis. So the conclusion is at alpha 0.05 there is no significant relationship between performance score and salary. Third, response variable is salary, predictor variable is age. Firstly, hypothesis, null hypothesis, beta I equal to 0. Alternative hypothesis, beta 1 not equal to 0. Step 2, F-test. F-test is equal to 2759.772. Step 3, critical value. F 0.05, 1.998 equal to 3.84. Compare and decide. Since F-test 2759.772 more than 3.84, we reject H null hypothesis, which is H null. At conclusion, at alpha 0.05 there is a statistically significant relationship between age and salary. For the fourth question, use a p-value to test for significance of the individual coefficient and comments your results. So this is our table. For the interpretation, experience and age are statistically significant predictors of salary, which is p less than 0.05. Second, performance score is not statistically significant at the 5% level. So for the fifth question, do the regression analysis by considering the R-square, adjusted R-square and regression equation for firstly one predictor, x3 age. This variable alone explains 73.4% of the variance in salary, making it a very strong single predictor. It outperforms both experience and performance score significantly. The high R to the power of 2 and adjusted R power of 2 indicate it is a reliable and meaningful variable when predicting salary on its own. So that is our table. Addition statistic ANOVA and ANOVA. So for the second one, which is two predictors, x1, x2, experience and performance score, based on the regression statistics and its ANOVA table. This combination gives a high R power of 2 of 0.774, which is much stronger than using either variable alone. The synergy between experience and performance score allows the model to capture a broader range of salary determinants. This model is efficient and accurate with just 2 inputs. Lastly, 3 predictors, x1, x2, x3, which is experience, performance, score and age. Based on its regression statistics on the table, this model yields the highest R to the power of 2, which is equal to 0.775, meaning it explains 77.5% of the variance in salary, including all 3 predictors, slightly improves the model, even if some variables like performance score contribute less individually. This model gives the most comprehensive and accurate prediction. Question: determine the best regression equation for predicting your project. Give your evidence. So this is our evidence. And for the final conclusion, best single predictor, which is age, x3, R square equal to 0.734. Best 2 predictors, which is experience plus performance score, R square equals to 0.774. Best overall model, x1, x2, x3, all 3 predictors, R square equals to 0.775. So best regression equation, salary, beta null plus beta 1, experience plus beta 2, performance score plus beta 3, and age. Although age alone is strong, adding the other variables gives a slight improvement, so the full model is the best. So for the conclusion for our project, the analysis confirms that education, experience, and job title are the strongest predictors of salary. These insights are valuable for employers designing of compensation structures, and individuals planning career growth. So let's take a look. For education, it has higher degrees, for example PhD, masters, correlate strongly with higher salaries. For experience, salary increase steadily with years of experience. For job title, positions such as director or manager command higher salaries. For gender, a noticeable salary gap exists, with males earning more on average. For location, urban and suburb workers earn slightly more than rural workers. So future work could include advanced machine learning models for more accurate salary prediction. Secondly, exploring interactions between variables, for example, education plus job offer. Lastly, analyzing bias and fairness in compensation across demographic groups. So that's all from us. Thank you.